Hey everyone, this is Nate again. In this tutorial I'm going to be going over a basic color sensor following tutorial for the FLL into orbit game field. So basically we're going to be focusing on following lines and then also detecting lines to maybe stop your robot when it hits a black line, things like that. So let's start with following lines. So the first thing you want to do, let's start with this, is connect your robot. And once you're connected, we connect through Bluetooth to ours. You want to go to port view. So you want to place your robot color sensor on a black surface and capture that number it gives you down here. So let's just say, we'll just go with the higher version of the number. We'll just say 2. So we'll say black reflective light 2. And let's put it on a white surface now and let's capture that. So on a white surface, let's go for the higher again. So let's just, actually you want to go for the lower one in the white surface. So let's say, we'll go right in the middle actually. Sorry about that. Let's say 60. Let's just go right in the middle for this demonstration. So I just put it back on a line, or on a black line. So okay, now that we have the values 2 for a black line and 60 for a white line, let's focus on the tutorial now. So this basic program that we're going to be going over is assuming that you start your robot on a line, and then we'll be focusing on following that line. So the first thing you want to do is grab this loop block right here. Basically what this block does is whatever functions you put inside of this block, it will repeat that until you decide to tell it to stop, kind of thing. So let's say you wanted to move your arm up and down, like half a rotation up, then half a rotation down, and you had to do that 3 times separately. So rather than write a huge code out, really long horizontally, you could just put that function in the loop block and then just type in 3 times, and it'll repeat that function 3 times, and it's a lot faster and easier. So, alright, now that we have our loop block, what you're going to be wanting to do is put a switch inside. Let's scroll a little bit up. Actually, I'll drag this up with us so we can, sorry about that, so we can remember our values, because we're going to need those in a second. Alright, actually, I think I accidentally did not connect these, so let's see. Let's just erase this switch again. Let's put the switch back inside. There we go. Okay. Alright, so now that we have the switch inside, first thing you want to do is set the switch to a color sensor mode, because it has all sorts of sensors in here. So color sensor, compare, reflective light intensity is what we're going to be working with today. So reflective light intensity basically means that your color sensor will shine a light onto the field, or the surface, and the light is going to bounce back up and measure how much light it gets back. So if you're on a white surface, the light will reflect a lot more than if you're on a black surface. That's why your values are different. If it's white, you can see you get 60 reflective, and if it's black, you only get 2. So that's basically what reflective light is. So let's set it to sensor 2. We'll use that sensor today, color sensor 2. Alright, let's move on. So to adjust this block to your color sensor, first, you select your sensor, of course, like I just mentioned. And then what you're going to want to do is, if you're following a black line, you have these functions in here. So you have equal to, not, or equal to, greater than, or less than is the ones, you'll mainly be using. So with the black line, basically you put a threshold in here, and then you put, whatever function you want, whatever math equation. So in this case, we're going to say we want to follow, a black line, which is low. So we're going to say, let's just type in like the value, like 8, okay? And then we'll say less than or equal to. So basically what this is saying is do a certain function when the color sensor reflective light intensity is less than or equal to value 8 of 8. So if we have a black reflective light intensity of 2, 2 is less than 8, so it'll, do a function with that sort of line. The reason that I have 8 and not 2 written in this value threshold is because sometimes your threshold on a black line will fluctuate a little bit. On some parts of the line maybe I'll have 2, on other parts of the line I might have 4. So that way I just typed in 8, so I give it a little bit of leniency, and a little bit of give with that. So now that we have targeting the line, we want to put in a certain function. Like, once our sensor sees the line, what do we want to do when we see the line? So in this case, we want to follow the line. So let's work on putting in that function. So what you want to do, let's just start with this. Just put in 2 drive blocks. So the reason you have 2 drive blocks is basically because when you follow a line, you have to be driving, right? So that you need the drive blocks to do that. So when you first drag drive blocks in, you want to check, make sure that they're plugged into your drive motors. In our case, B and C are the drive motors. But when you're following a line, you don't want to have like a limit on your rotations on the drive motors, because basically you want your limit to be the loop and not the drive motors. So you want to just, if you click those drive motors blocks and click on, it'll get rid of that rotation for you. So that way, basically, you're saying drive forward unlimited, and then we'll stop it at some point. We'll talk about the rest later. So when you're following a line, what you want to do is you don't want to follow it at 50% speed, because that's pretty high. So let's follow our line at 10% speed. All right, 10%. Just type all these in at 10%. So basically, how you follow a line is, or a basic way to follow a line is, basically you say, if I'm over a black line, slowly turn right, and then that'll put you on a white surface. If you turn right, it'll put you on a white surface, and then you want to say, if I'm on a white surface, turn left. So basically, you're going to be, in a sense, zigzagging across the line. So to do that, what we want to do is, let's just put a turn in here. So we'll do a value of 10 there, a value of 5 here, and then a value of 10 here, a value of 5 here. So basically, this is saying turn one direction if it sees a black line. If it does not see a black line, turn the opposite direction. So, if it sees a black line, it'll turn one direction. If it sees white, it'll turn the other direction, basically, is what you're saying. So that's what the check mark is for, and the X, it means if it sees it, do this function. If it doesn't, do this function. Okay, so now, all right, that's the basics of it. Now, however, you have your loop still. Remember, so the reason we have the loop is because you want to be repeating that zigzag motion until, let's say, you drive, to the end of the line, or, you drive 2 rotations down the line. So, however, right now we have our loop set to unlimited. So this is not going to work the way it is, because a unlimited loop means that you're just going to keep looking to follow a black line just forever. So in the into orbit Lego board, we don't have an infinite black line, and so we want to limit how far we follow a line. So let's say, well, you can put different limits in here. We'll just say motor rotations, because it's pretty easy to understand. So basically, let's say we want to follow a line for 1.5 motor rotations. Alright, so let's see. What we do is we switch this to our drive motor. That way it measures our drive motor, right? We say, here's another, list of those math functions. Alright, so we're going to say greater than or equal to, because let's say we drive, 3 rotations. If it's 3.1, it's going to stop, Or in our case, we're driving 1.5 rotations, but say, when it reaches 1.5, or if it's anything greater than 1.5, it's going to stop, or do whatever function we tell it. So now here's the rotation section. So your threshold, let's just say 1.5 rotations, okay? So when measuring, when interrupting your loop with a rotation block, you actually want to go to this yellow section, click motor rotation in here, and you want to reset it before you even run your program. That way you're starting from your motor will start from base of 0. That way, it'll, when it builds up to 1.5 rotations, it'll do whatever function you tell it to do, If you do not have this reset block, basically, like you can see my motor's down here, my drive motor B is already at 1.8 rotations. So basically, as soon as I start this program, it's going to completely skip the line following and move to something else, because I'm already greater than 1.5 rotations. So if you add this reset block, as soon as I start my program, it'll reset. Actually, I can do that for you. If I disconnect this and just run the reset only, you should see my reset block reset. See? So now my values are 0. Alright. So let's connect the rest of the program together. So, alright. So now that we have this giant section is just for following a line. So now let's say we want to, turn after we follow the line and then move an attachment. Alright, so what we do, let's go back to the basic section, action section, and let's say we want to turn. So, put that there. and then we will turn. So let's put this, let's just type in 50. So we turn a little bit, 10% speed driving, and we'll say 0.5 rotations. Alright, and then now we want to spin an attachment, let's say. So we'll spin motor D, just say 10% power, and we'll say 0.75 rotations. So basically this program is split into two different sections. So you have your line following section, which is this section, and then you have your function section, which is this, which is what you want to do after you're done following the line. So in our case, we're just going to turn our robot and then pick up an attachment. So let's download this program on the robot, see how it works. So now that you guys got to see how to follow a line, what we're going to be talking about is like intersecting a line. So like if you want to drive into a line and intersect it, and then let's say you want to stop on the line, or I don't know, you want to do a function after you reach that line. So this is what we're going to be talking about. We're going to be working with the same values, the black and white values up here. So what we're going to be talking about is going from the base down to the rail where you drop those carts. And there's that line right there we're going to be intersecting. So we'll talk about that. So let's say we want to intersect that line. The first thing you want to do, drag some move blocks because you have to drive to it. So like I said, you want to drive on unlimited. You don't want to have a limit on your line. And then we'll pull out this. So basically what we're going to say is drive forward unlimited until you reach a black line and then stop on the black line. Okay? So we're going to, this makes us drive forward unlimited, turning it on. So now let's say black line. So color sensor, compare, reflective light. Same thing, select your color sensor. See where we're at, less than or equal to. We'll say 8 again. And then now we want to type in what sort of function we want to do after we reach the line. So in our case, we want to stop on the line. So let's say turn off our drive motors. So basically this is the program where you say drive forward. Okay, drive forward. When you reach the black line, stop. So this one's a little bit easier to understand. So let's run our program real quick. As you can see, we actually did not stop on the black line. We stopped sooner than the black line. So what could that have been caused from? So that is caused from, with this year's board, it's the background of the board is actually really dark in different areas of the board. So you have, like meters printed on the surface of the board and things like that, which are very close to like, a blackish color. And in that case, when our sensor actually scanned one of those meters, when it went over one of those, it actually triggered the sensor because it was close enough to the color black and said stop. So how do you fix things like that? So this is how you fix them. Basically what you can do is you can figure out, once you figure out what sections are triggering your robot early, like in this case it was one of those meters printed on the board, what you can do is actually bypass those sections. To do that, you add an additional block. So what you want to do is we go in here, actually we shouldn't be following the line at 50% power, let's say 15% power. So to do that, like I said, what you do is you just go in here, you click, you basically make your robot drive forward. So then at that, drive forward enough to where you pass the meteor or whatever is triggering your robot, and then you activate your sensor. So then let's say in this case, I have already calculated it to be 3.2 rotations. Will get us close to the line and past the place where our sensor was triggering earlier, which was that meter. So we'll pass the meter and then we'll trigger our sensor and start following the line from there. So let's go ahead and give this a shot and take a look at it. Alright, that seemed to work. So if you wanted to do a function after that, let's say you didn't want to stop on the line, basically all you can do is you can just add this, let's say you want to turn your attachment motor 0.5 rotations, you could do that. Or let's say you want to drive a little bit farther than the line, you could drive 0.5 rotations past the line, then activate your attachment, you know, anything like that. So basically this follows your line, and anything, or this intersects your line, this section of the program, and then anything after that is what, you know, functions your robot will do. So I hope you guys enjoyed this video. Hope it was informative enough, you know, about basics on color sensors and a basic line following program for you. Good luck in the FLL into Orbit challenge this year, and please subscribe or comment if you have any questions and you want to see future videos. Alright.